Once upon a time, two fellows wrote a protocol on a paper napkin. And then it was used for everything. Happily ever after. Welcome back to the MVPN video series. In this video, we introduce and then take a deep dive into the BGP MVPN C-Multicast routes. Additionally, we introduce a new extended community created exclusively to support these routes and their distribution. Let's begin. The topic of BGP SAFI and NLRI was introduced back in video 14. In particular, we discussed how most of the features of PIM have been adopted to BGP MVPN. For a refresher, refer to video 14, link in the description box below. But in this video, we continue that journey by introducing the route, or rather the set of route types that essentially replace the PIM joins via BGP MVPN. And those are the BGP MVPN C-Multicast routes. In reality, the BGP C-Multicast route is a set of two distinct route types. Why two? Well, one to replace the PIM joins for the *G trees or RPTs, and one to replace the PIM joins for the SPT or S-G joins. Appropriately, they're called the shared tree join and the source tree join respectively. Now, they're identified in the NLRI with a field called the route type. Specifically, route type 6 is for the shared tree join and route type 7 is for the source tree join. The actual structure of the two routes, however, is identical. If you're familiar with PIM join messages, this should not be a surprising revelation. Even PIM join packets have the same exact packet format, and the differentiation between the RPT and the SPT join packets, that occurs via the flags in the packet. Stating it another way, there are bits that are set or unset depending upon the join type in the packet. For an in-depth coverage of all things PIM, you can refer to our CCIE JNCIE IP Multicast lecture series. Link also in the description box below. Now then, before we talk about the packet itself, we must understand that this MVPN framework, this new Next Generation MVPN framework, BGP SAFI included, was designed from the very beginning to cover not only the traditional intra-AS scenarios, but also the inter-AS scenarios. This has some implications on what fields exactly will each MVPN packet need, and also the contents of those fields. Therefore, as we discuss the fields of this particular packet, we'll actually skip the first two and cover them after the rest of the fields, and that way it should make a little bit more sense. So, starting from the third and the fourth fields, together they describe the source IP. And again, just like the auto discovery routes, because the same NLRI is used across IPv4 and IPv6, there is a length factor associated with the actual address to indicate that difference. That's why the length is carried explicitly in the source length field. The content of the source IP field also is extremely important, and it does vary depending on the route type. So let's discuss. To understand the field itself, it is beneficial to understand what causes this route to be created in the first place. 10 points. Points equal our respect and cannot be redeemed for anything of any value whatsoever. If you guessed a PIM join message. So the trigger is a PIM join message, but could be anything that changes the state of the multicast table such that a group with an oil is created. Extrapolating that, in simple terms, PIM RPT joins would cause shared tree routes to be created, while PIM SPT joins would cause source tree routes to be created. Let's focus on the shared tree route first. We have established that it is created because of a *G join. So then the next logical question is, what is the source IP listed in the PIM RPT join? 10 points, once again, points equal our respect and cannot be redeemed for anything of any value whatsoever. If you said that the address of the RP or the rendezvous point is the address that is carried in that field. So in a shared tree join, the multicast source would be, or rather should be, the CRP address. Conversely, for a source tree join, this IP will be the multicast source itself. This route is usually generated as a result of either SSM in the network or an SPT switchover in an ASM scenario, but again, if you realize, very similar to how a PIM join operates. The last two fields are the multicast group length and the multicast group. Once again, the length describes the actual group, whether it's an IPv4 or an IPv6 group, and the group, well, that's just the group. That's just the group that a receiver wants to join or is interested in. So in other words, a CG that the recipient has signaled interest in. As promised, we circle back to the top of the packet and now we have the RD. Because the C-Multicast route is used for one of those scenarios where both intra and inter-AS scenario is relevant, the nature as well as the purpose of the RD here is somewhat different from the traditional sense. The RD here plays a role not only that it plays traditionally for route distinguishing, but also combined with the next field, the source AS, it plays a role in the inter-AS operations on the MVPN ASPRs. Inter-AS scenarios are outside the scope of this particular video, but for our intra-AS scenario, the RD is derived from the PE that advertises the IP address used in the source IP field. So I should repeat that again. The RD in this packet, it is derived from a remote PE that advertised you the IP address that you're using in the source IP of this particular packet. So it is not the local PERD, and as is usually the case for most routes, but it is the RD of the PE that advertised the CRP or the CS IP address to you via a VPN v4 route. This still keeps the route unique in the core of your network, but makes the job of the ASBR a little bit easier. The how of that needs to be covered separately, but we will keep this particular video strictly intra-AS. Next is the source AS, which is also applicable only in the inter-AS scenarios and out of the scope for this particular video. Just for completeness sake though, the local BGP AS, the AS configured on your local PE, should populate this field in intra-AS scenarios. And that's all there is to that route. Let's move on to the actual functionality of this route in a BGP signaled MVPN. Now, the route itself is simple, but there are some implications with its implementation. Suppose we have an MVPN as indicated in this topology. 3 PEs, PE1, PE2, and PE3, 3 CEs connected to those PEs. Going clockwise, starting from PE1, let's identify some key aspects of this MVPN. Behind P1, there is a rendezvous point, CRP, and for this scenario, let's just assume that all the functional multicast groups of this customer, they map to this rendezvous point. So something like 224/8, that maps to this rendezvous point. Next is PE2, and the customer site behind PE2 contains a receiver CR, which is subscribed to an ASM group. That's going to become important. Finally, the site behind PE3, there is a source CS that generates a multicast flow on that same ASM group that CR is subscribed to. So let's begin. CR starts things off by sending in IGMP v2 membership report to its local PIM-DR. This PIM-DR creates a state in its MRIB and creates a PIM join to send upstream. The source IP in this join would be the CRP, as it is a *G or an RPT join. So the DR looks up the RPF neighbor for that IP address, that is the CRP, and sends a PIM RPT join towards PE2 because it's across the VPN. But since this is the end of the line for PIM, PE2 must now use BGP to move the join further on its way. It does so by originating a BGP C-Multicast shared tree route. In a fairly typical BGP scenario, This route would then be advertised to all of the neighbors in the MVPN, quite possibly using a scaling technique, maybe a route reflector. What happens next in this scenario is a cause for concern. So all the PEs in the MVPN, in this case PE1 and PE3, will receive the route and they must process it. Once it is processed, PE1 would realize that the CRP sits behind it in the customer side and will convert the BGP route back into a PIM join and send it over to the CRP. All's good here. But for PE3, that route is useless, as it does not really have a way independent of PE1 to get that message to the CRP. There's no backdoor here. So what would it do with the route? Well, without any further changes, the route would stay in PE3's BGP table endlessly till maybe it is rescinded from PE2. This is not optimal, especially for MVPN deployments with a large number of PEs and also maybe a large number of states. Let's look at a similar scenario, but this time for an SSM join. As a side note, an SPT switchover scenario would be similar, except for the very first step, which is the IGMP report. That won't happen in an SPT switchover. Once again, the CR starts things off by sending an IGMP v3 SSM membership report to its local PIMDR. The PIMDR creates a state in its MRIB and then creates a PIM join to send upstream. But the source IP in this join would be CS because the join is an SSM join and the source is known. This time, the DR looks up the RPF neighbor for the CS's IP address and sends a PIM SSM join towards PE2. Once again, this is again the end of the line for PIM and BGP must be used. This time, PE2 will generate a BGP C-Multicast source tree route. Once again, like previously, the route will be advertised to all of the neighbors in the MVPN. And once again, PE1 and PE3 will receive the route and must process it. This time, it is PE3 which realizes that the CS sits behind it. It'll convert the BGP route into a PIM SSM join and send it over to the FHR for the CS. All's good. But this time, the route is useless for PE1. And again, without any further changes, the route would stay in PE1's BGP table endlessly till it is rescinded again from PE2. Not optimal, especially for, again, large MVPN deployments. That's what we are concerned about. So, how do we fix it? Before we introduce the quote-unquote fix, a caveat. There is a chicken and an egg problem up ahead. In order to tell you about how the PEs use this fix, I need to introduce it and its structure. And since that is so intertwined with its use, you really need to know how the PEs utilize the fix in order to understand its structure. So my advice is to watch the whole section patiently, and things should make sense by the end. If they do not, watch it again and pay attention to any details that you missed. They're all there. I earnestly believe that, and I promise you. So, to solve the problem of route retention that we met in the previous scenarios, RFC 6513 and 6514 introduce a brand new extended community. This is called the VRF Route Import community, and it is originated by the MVPN PEs. The structure of this community is set in stone. So for example, a route target could be AS specific or in AS:NN format, or IPv4 address specific, which is IPv4 address:NN format. But for the route import, the only accepted legal structure is the IPv4 specific structure, so the IPv4 address:NN format. Furthermore, the IPv4 address must be a local address on the originating PE that is reachable, so probably derived from a loopback. The second part of the community, the local specific part or the NN, essentially identifies an MVPN VRF on the originating PE that generated the community. This is almost never user configured. So that NN, almost never user configured, and it is chosen by the router implementation pretty dynamically. So for example, the router may choose 100 for VRFA, 101 for VRFB, and so on. So in case of VRFA on that particular router, say with a 1.1.1.1 address, the route import community then would become 1.1.1.1:100, and for VRFB it would become 1.1.1.1:101. A sharp viewer would have noticed that I have used the word originate quite a few times so far, but a PE just doesn't originate a community by itself, does it? So the community must be attached to a BGP NLRI, and herein lies the chicken and egg problem. You needed to understand the structure of the route import extended community before we could discuss how it is actually used in BGP MVPN. So let's get to it. The route import community is actually attached to, and this is interesting, the VPN v4 or VPN v6 unicast routes. Yep, you heard that correctly. VPN v4 or VPN v6 unicast routes. So what's the point of that? Here's one cryptic clue that I can give you. Sites or MVPN sites that have been configured as receiver only do not, in fact, they must not attach this community. This will become important in a second here, so do ponder upon why that might be. So that is how the route import community is distributed or advertised with the VPN v4 and VPN v6 unicast routes, but that is not how it is used. Far from it. Imagine our two previous scenarios for a second. The problem, you might say, is that there is no filtering mechanism at the sites that do not require the C-Multicast routes. PE3 had no use for the share tree route, and vice versa, PE1 had no use for any CS-rooted source tree routes. So it is the route import community then that provides that filtering mechanism. You see, once the route import community has been distributed throughout the MVPN, and this would be via the layer 3 VPN unicast routes, technically all the addresses have a route import associated with it. Now, when an MVPN PE sends a shared or source tree join, it can look up the route import for either the RP or the actual source and use that route import from the unicast route as the route target for the MVPN C-Multicast route. So once again, I'll repeat that. It can look up the route import for any of the sources and use that route import from the unicast route as the route target for the MVPN C-Multicast routes. The routes are advertised similarly. The C-Multicast routes will be advertised exactly in the same manner, but at the recipient sites, those routes can now be filtered based on the route target community. This is why you might be able to see, at least in theory, the receiver-only sites or the MVPN sites that are not supposed to have any sources, why they never tag their unicast routes with route imports. This essentially ensures that the C-Multicast messages cannot be created towards any addresses in these sites, and in fact they become true receiver only. They're forced to be true receiver only. Well, too much talking, too few pictures. Let's visualize this. Let us start from the CRP and how configuring a BGP MVPN would affect the advertisement of that address to the rest of the layer 3 VPN domain. The first part remains the same and really is not part of the L3 VPN process. This is the initial advertisement of the RP's IP to the L3 VPN PE. This is still any IGP, eBGP, or static route method that we have used before, anything of your preference. As before, the PE will create a local VRF RIB entry to point the route back to the advertising CE. Next, the PE originates the route in L3 VPN via VPN v4 or VPN v6. This is where, now, in addition to the RD and the RT, the route import of the VRF is also attached to the route. Once again, totally dynamic with really no configuration options, maybe other than designating a site as receiver only. That would result in no route import attached at all. In our case, the MVPN VRF number was chosen to be 1 by the PE. Prepend that with the PE's IP address and you may get something like 1.1.1.1:1. This route is advertised to all the VPN v4 BGP peers, same as before. Depending on the route targets, and these are the route targets of the original L3 VPN, the receiving PEs may keep the route, but this time they would also keep the route import information in their local BGP tables. So both PE2 and PE3 know that CRP is routable via PE1, and additionally it has a route import value of 1.1.1.1:1. Let's drive this point home with another example. This time, pay attention to PE3. First part, once again, just the advertisement of the S from a local CE to PE3. Nothing new. PE3 creates the local VRF RIB entry and proceeds to originate the route in the L3 VPN. Once again, in addition to the RD and the RT, PE3 attaches the route import of the VRF to this route. May I also be so repetitive as to say totally dynamically. This time the route import value lands to 3.3.3.3:20. The IP address identifies PE3 in this MVPN, and 20, well, that was the locally significant VRF VPN number. Now this route is advertised to VPN v4 or VPN v6 peers. Once again, after the route target based filtering at the receiver sites, the recipient sites, I shouldn't say receiver sites, the route is accepted into the remote PE's VRF BGP tables. Most important part, the accepted routes have that route import information associated with them. To recap, PE1 and PE2 have a routing entry for CS via PE3 with a route import value of 3.3.3.3:20. We have the information distribution completed. Time to actually utilize the route import to our benefit with the C-Multicast routes. Before we explore the actual C-Multicast route distribution, a word on how to read this diagram. The green boxes depict the VRF import and export policies and are only included for the boxes they are relevant for, and that would be PE1 and PE3. The orange box depicts the VRF unicast RIB, and again it's only included for the receiver site, which in our case is PE2. Let us look at what the boxes actually indicate. From PE1 and PE3, the export route target list is unchanged. Unchanged from a typical L3 VPN scenario, that is. It is either configured via a list of route targets or via a policy, but it's immaterial to our MVPN scenario. For the import route targets, there is an important change. The route import community, the one that the PE advertised tagged to the unicast routes, well, its value is added to the list of acceptable import RTs. Essentially, think of that import list as being appended to with one more value. So if the previous import route target list was 100:100 for the L3 VPN, that's a full mesh setup if you will, then the route target import list on PE1 would become 100:100 and 1.1.1.1:1 because that's the route import value that PE1 advertised. On PE3, this list would be 100:100 and, you should have guessed it, 3.3.3.3:20. It's that simple. The PEs are basically changing the list of acceptable import routes. This, in fact, will help us with the filtering of the C-Multicast routes, and we shall see that, well, now. So let's start from CR. IGMP join, just like before. This is a star comma G. The DR generates a PIM join in response and sends it to PE3. But when we visited the scenario last time, I sort of lied to you. Well, at the very least, I held back some information because we were not ready for it, in my opinion. Remember the chicken and the egg? So this time, the PE once again creates the BGP C-Multicast shared tree join route, but in addition to the C star, CG information, which is the CRP, CG information, it actually looks up the unicast route to the source CRP. This is not unlike traditional MVPN because the VRF has always looked upon for RPF information. What is new here is that in addition to the RPF information, the PE is also looking for the route import value that it knows it must find here in this particular entry if the MVPN is correctly configured. So for CRP, it will find the value and uses it as, yes, a route target for the multicast route. With this new information, the route is now complete in a neat little bundle, and we can send it out to our peers. At each of the peers, the route is processed like any layer 3 VPN route, in that the PEs are looking at the route targets and comparing them to the import list. You can already see what will happen here, can't you? PE1, it matches 1.1.1.1:1 successfully with a local route target in the import list, and as a result, it keeps the route. But PE3, well, the route target is not in the import list for PE3, and it refuses the route. Filtering successful. And moreover, based on a well-known, time-honored, scalable technique, that of the route target. Let's drive this point home with one last example. Once again, maybe we should start a drinking game. Every time I say once again, well, or so, at the start of a sentence, let's take a shot. So where was I? Yes, once again. We start from the CR. IGMP v3 join this time, or IGMP v3 report this time. The DR generates a PIM join in response and sends it to PE2. Armed with the new information, PE2 now creates the BGP C-Multicast source tree join route, but in addition to everything else, the PE is looking at that route import value associated with the CS. It finds 3.3.3.3:20 this time and uses it. And you can already guess as the route target for the C-Multicast route. Route's now complete. Neat little bundle sent out to the peers. The routes received at the remote PEs and compared to the RT import list. This time 3.3.3.3:20 matches positively on PE3, which keeps the route correctly, not so much on PE1 where the route does not match any targets and is rejected. Hopefully that clarifies the operation of C-Multicast routes. It's not the most complicated idea at the end of the day, but only if you understand the mechanisms, the pretty complex mechanisms sometimes, associated with it. Up next, we build upon our already functioning Profile 3, which already uses BGP Auto Discovery, and further move it towards BGP by incorporating BGP C-Multicast signaling in the core, replacing the CPIM essentially between the PEs. For the curious or those looking for a head start to do it by themselves, that profile will be, well, you know what? Let's make that a quiz. Look up the MVPN profile document and share your answers as to what that profile should be in the comments below. Let's see if we can get an argument going on here. I should not have to say this, but it is 2019 after all. Please be nice to each other. Till then, I'd like to thank you for joining us and urge you to stay tuned for our next video. Thanks.